Welcome to this video lecture on the subject electronic circuits. In this lecture, we are going to discuss about Wien Bridge oscillators. So what is the need for Wien Bridge oscillator? So this is the RC oscillator which is used to produce the low distortion output, and the output is in the form of sinusoidal waveform. So this is used for low frequency oscillators, audio frequency oscillator, signal generators and testing and measuring equipments. And what is meant by Wien Bridge oscillator? It is a sine wave oscillator which consists of an RC bridge network and an amplifier circuit. So RC bridge network is in the form of Wheatstone bridge. It is used to provide the positive feedback to the RC amplifier circuit. So this consists of an R1 RC1 in series circuit and R2 C2 in parallel. It also consists of R3 R4 voltage divider network and also an amplifier circuit. So these are the components of Wien Bridge oscillator. And let's see the circuit diagram for Wien Bridge oscillator. So as we have discussed, it consists of a Wheatstone bridge and also an amplifier. So in this case, amplifier is a two-stage network. So as we can see here, there are two transistors Q1, Q2. There are two stages of amplifier circuit. Each provides a sinusoidal output which is 180 degree phase shift. So the total phase shift of this two-stage amplifier circuit is 360 degree. So the phase shift provided by the Wien Bridge network is 0 degree. So it consists of RC and also lead lag network. So working of Wien Bridge oscillator. So let's see the working in detail. So the positive feedback is provided by the Wien Bridge network. It consists of R1 C1 in series and R2 C2 in parallel, which acts as the low pass filter and a high pass filter. So it consists of an R3 R4 which is the used for providing the negative feedback. So what is the need for negative feedback here is that it provides the frequency stability. So it provides with constant amplitude the output is stable. So it is used for gain control, so and also low distortion output. So this is the important criteria in the Wien Bridge oscillator, so which is used for low distortion output and also it is used for stable output. And here we can see working of Wien Bridge in the waveform format. So the first is the feedback network and second is the first amplifier and also second amplifier. The output of first amplifier is provided by the 180 degree phase shift, and again the second amplifier output is also 180 degree phase shift. The total phase shift is 360 degrees. So RC network does not provide any phase shift. It is used for providing the positive feedback and also gain control, which is used for generating the stable output at the output of Wien Bridge oscillator. So it consists of R1, R2 and C1, C2 in the bridge network and feedback resistors for gain control. What are the advantages of Wien Bridge oscillator? The circuit is simple, it is easier to design and implement in the oscillator circuit, and also it provides stable frequency output, and also it provides clean sine wave with low distortion and wide frequency range. It is operates across the broad spectrum of frequencies. And disadvantages are gain control. It is precise gain control is needed for stable distortion free oscillation, and also the component tolerances, frequency affected by resistors and capacitor tolerances, and high frequency limitations. And applications of Wien Bridge oscillator, it is used for audio signal generators and musical instrumentation for testing and measuring equipments, and also telecommunication in the transmitter circuits. The mind map shows the important concepts of Wien Bridge oscillator. So circuit consists of an RC bridge network and positive feedback and low distortion and stable frequency is the important advantage, and applications signal generators and audio frequency generators. Let's take the assessment. At the resonant frequency, what is the phase shift for the output in the Wien Bridge oscillator? So the answer is A, 0 degree. And which of this is incorrect for a Wien Bridge oscillator? So it is difficult to tune. The answer is C. Thank you for listening this lecture.